So to do these, we need to quickly review our theorems that allow us to prove triangle congruence. So remember, it was just the 5 of these. And I haven't done this, but maybe I'll do it right now. Somehow I want that to stand out. It's only those 5 things that can prove triangle congruence, right? If you feel good about that, maybe don't worry about doing this, but otherwise add this note. Only those 5 theorems can prove triangles to be congruent. The key, if you remember from Friday's work, is making sure they're in the correct order, but also seeing other ways to get those pieces to be congruent. Okay? So let's go back to these. This one's easy. Are these triangles congruent? How do we know? Like which theorem? Side, side, side. Good? Okay, this one's already marked for you with the green in the middle, but just know that most of the time it won't be. So you need to make sure you can see what is the property that allows us to mark the green X and say that that line is congruent to itself. What's that property called?
Reflective.
It's on here on the back.
Reflective.
It's this one, yep. So a line or angle, in this case a line, is congruent to itself. That's why we can say that X, put that X there. Okay? Now let's answer if it's provable. Do any of those apply? Well, remember we started talking about labeling, so S, A, and then we have this side length for both. So this is side, angle, side. Okay? All right, next one. If I start labeling, I see a side and an angle marked as congruent. I also see an angle over here. Is that okay? So if you notice, we have like a side and angle together, and then we skip something and go to another angle. Is that okay? Okay? Which theorem is this? No. Angle, angle, side, or side, angle, angle. But we can mark this line. Why? Why is it okay to mark that as congruent to itself? That's the reflexive property, right? And with that, we can also mark another one on here. Anybody know what? That counts as a side. So what other choice do we have to prove this as congruent? Angle, side, angle. Okay? If we choose to use the reflexive property on that line in between, now we have angle, side, angle as well. And you're going to find that when we get into these proofs, there is often more than one way to do it. Sometimes there's 2 or 3 ways. Okay, how about this one? Why are these blue tick marks or arc marks here? What kind of situation is that? They're given, but I'm asking if they weren't, what would you say? Yeah. Those are vertical. Okay? If these happen to be parallel, why would these 2 angles be congruent? Alternate interior, right? Parallel line, alternate interior. Good. But as it stands, that was all given, so which one is this? That's angle, side angle. Everybody see it? Alright, last one. Again, we have the reflexive property. This time it was given. So which one is this one? Yep, side, side, side. I don't know if you can see, but there's a green mark down
I
there
didn't
too.
even see that.
Yeah, those are hard to see. Is that better? Okay. So yeah, these are side, side, side. Good. So grab that sheet, and I think we didn't quite finish, right? Did you finish? Okay.
This one?
You finished? Oh. Did you? Okay. Yeah, that one. You finished? Did we check? We only checked. That's what it was. We didn't finish checking. Okay. Let's pick up with number 8. I think we might have checked it on Friday, but we can check it again. So just a reminder that just because you see a right triangle doesn't mean for sure that you're using HL. In this case, it happens to be that one because you have the hypotenuse and a leg marked as congruent. Okay, so that one's HL. Next one, side angle side. Well, where's the other side? I didn't mark it. Yeah, it's this QS. So QS is congruent to itself. That's the reflexive property, and then we have side angle side congruent. Okay, number 10. Is angle, angle, angle good? No. So remember it was on that board. That board had the 2 that don't work. And so no, that one doesn't work. And there's no way to get any other information. Like there's no reflexive property or anything like that. Alright, this one. What are these kind of angles called? Those are vertical. Usually they're not going to be marked for you, so just make sure you keep seeing them. Like this one, not marked, but they're still vertical, right? So if we mark those vertical angles as congruent, now we have angle side angle. How'd that row go? 10, number 10 to 12. Next row. Can we use HL? Yeah. Is it just because it's a right triangle here? No. It happens to show us that the hypotenuse and one of the legs are congruent. Okay, next one is side, 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 and then last. Are these isosceles triangles? Is this an isosceles triangle? Yes, it is. 2 sides are congruent. Also, the 2 base angles are congruent, right? Is this an isosceles triangle? Yes. 2 sides congruent, 2 base angles congruent. Does that mean that they are congruent? No. So we don't have enough. It says markings, it should say aren't right. And what I mean by aren't right, it doesn't tell us that in triangle YZU that the lengths are the same as BWX. So we can't prove congruence. Even though there's tons of markings on this picture, it's not enough. How'd you do on that overall? Okay, seeing lots of thumbs up. Do you feel ready to do some proving? I'm not saying we're there, but you feel like you're getting there? Maybe? Okay. Alright, well, we're going to talk about one thing and then do proofs to finish off the whole unit. So we're coming kind of close to the end of the unit stuff, actually. And that means tests coming up soon. Not this week. We'll get to it next week. Let's try one of these. We have these in town, these big radio towers. says a technician installs cables from a cell phone tower to the ground. To pass inspection, both cables must be the same length. Does this installation meet the cable length requirement? In other words, are they the same length? Okay? So I'm going to look at it if you want to talk to somebody. But let me know.
They're both 52, and it's my right angle at the bottom, so I feel like the other side would also be right angle. They're both the same.
Okay? Kyron?
Yes.
Why?
Because of the right angle. So what just came to mind was hypotenuse line.
Okay. Nothing? So, okay. A lot of people are saying because of the 90. Is that enough? Could we have it be like this? I don't know if this is... let's see. Let me think about it while I keep asking. Think about how to draw it. Bailey, what do you think? Are the two, again, we're questioning if these are the same.
This is just giving us angles.
Okay.
And no side lengths. And three angles. It's just giving three angles. Then
Okay. So AAA doesn't work. What do you think? Same as her. What do you think?
I want to say no.
You want to, huh?
Yeah, but
This guy wants you to say yes, because then he can go home.
I can't decide between yes and no.
I'll say yes. Because isn't there, if there's a 90 degree crescent, then the side one, the vertical from has to be.
No, not necessarily. If we were told that the two cables were the same distance, right? Like if we were told something about these being the same distance from the base of the tower, we would be okay. But otherwise, no. So are you saying yes or no? Okay, how about you, Sophia? Okay. Alright, lots of opinions. Good. I'm going to erase this just for a moment. Guys, here's really what we're asking, and this is what we're moving into for the rest of today. How can we use congruence to solve things? So, number one, you have to be able to prove that something's congruent, or be told. And then number two, we'll talk about how to use that to solve. And that's... The question here is, are these two triangles the same? Because if they are, don't you agree that the two cables must be? If the triangles are the exact same triangle, the two cables have to be the same, is what I'm asking. Do you agree? Okay. So here's what Sophia said. Does everybody see that the tower obviously has to be the same as itself? Assuming that the cables are hooked on to the same spot, at the same level. So yeah, the tower, we can use the reflexive property to say that it is congruent to itself, and now we have angle, side, angle congruent. So it's actually not hypotenuse leg, because we are trying to determine if the hypotenuse is the same. We don't know. But now that we know that the two triangles are congruent by angle, side, angle, are the two cables congruent? Yeah, for sure. Because we just said that the two triangles are exactly the same. And then if they are, then they have to be congruent. Okay? So I'm going to grab your sheet, this main sheet that we've been using, and look down at the very bottom. We will do proofs with this, but let's first talk about this theorem. It says once triangles are proven congruent. And so please highlight that in some form or fashion. Because if that is not true, you may not use this. You have to know that this is true first. In fact, before you use this sheet, let's kind of separate this from the other stuff up at the top. Okay? Once we know that two triangles are the same, it says the corresponding leftover parts that were not used are also congruent. That's what this theorem means. Now the wording is a tongue twister. Corresponding parts of congruent triangles are congruent. Do you see the CP? In fact, let's underline C, P, C, T, C. That's where those letters come from. Corresponding parts of congruent triangles are congruent. Well, what does corresponding parts mean? It is parts that make up the triangle. The word corresponding is pretty significant, though. Okay. Well, we do have corresponding angles. Did you just say that too? Yeah. Okay. Let's define that word so that we're all clear. Here's what that word is talking about. Matching parts. If you want to say it as kind of what we think, like my right shoe is the same as somebody else's right shoe, but not the left, right? It can't be left to right. So matching parts. Parts in the same position in each triangle. So in our example of the radio tower, this is the picture essentially, right? Here's our tower. We're talking hypotenuse to hypotenuse, base to base. This angle way over here to that angle way over there. Like it's the pieces that match up, right? It's the matching pair. So I'm going to stick with that word. I think it's probably the most descriptive. If you want on this, like it kind of gets a little bit messy, but you can show all the matching pieces.
So it was.
Okay. We should have how many parts that are corresponding? 3. Well, no, not 3 of each. So 6 pieces. What are the 6? Like, describe them. If you look at the picture, there should be 6 things that are matching up. What are all of them? Do you see 3 angles and 3 sides? That's what we're talking about. Like in a triangle, there are 6 parts. 3 sides, 3 angles. Each one has a buddy in the other triangle. Okay, so we're going to use this CPCTC. Everybody try saying it, by the way. Try again. CPCTC. It's a tongue twister. Okay, it's okay to mess it up. We're going to be able to use this to solve for other things. Okay? And we'll be doing proofs with this as well. So we just used CPCTC to prove that these 2 cables were congruent because we proved by angle side angle that the 2 triangles were congruent. So therefore the corresponding parts are congruent, which was the cables. That's what we cared about in that one. Sorry, pushed the wrong button. So let's go see this one I modified, but it was one of those kind. And there we go. Okay. First thing you have to establish is what? Look what we just wrote. What did we highlight at the very beginning? We have to know they're congruent, right? Are they? Like, do we know for sure that they're congruent? So that goes back to the 5. Those are the only ways that we can prove congruence. Do we know that these are? Look at them carefully. Okay, what theorem proves that they are? Okay, we have side, angle, let me circle it. Side, angle, side. Okay. Alright, well, now that they are congruent, how do we solve for x? It says find the value of x, so how do we do that? Huh? Well, we only do 180 when things add up to 180. Do those add up to 180 necessarily? So let's not do that. So now use CPCTC. What does it stand for?
First congruent triangles are congruent.
Okay, we just proved that the triangles are congruent. So now we're going to go corresponding parts are congruent, right? Use CPCTC to solve for x. Well, what are the corresponding parts that we're using? Those two are corresponding angles, right? They go together. So what's true about them? They are the same. So this is 2x plus 5 equals 3x minus 15. And by now, I'll let you do the solving, but x is 20. Okay? That's all. But what do you have to be careful of? 2 things. 1, you've got to prove that they're, or know that they are congruent first. And 2, you've got to make sure you're comparing corresponding parts. Okay? Like, don't correspond this to that. Those don't go together. Okay? Corresponding parts. Why don't you try that bottom one? Alright, so go here and put, this is CPCTC solving. So step 1, are the triangles congruent? For sure. So, do we know if they are? Let's mark. We have 84 and 84, that looks good. We have our 2 tick marks. So we have angle side, and then we have 52. So two arc marks. So are the 2 triangles for sure congruent? By what? Yeah. So this is congruent triangles by ASA. Check. Check that off. Okay. Next. I want you to be careful here. So if triangles are congruent, then corresponding parts are congruent too. Only compare corresponding parts. I'm going to put a word out here. I'm going to say caution. Only compare corresponding parts. So you got to be clear on what those are. Some of these examples are making that look super easy, and a lot of times it is, but sometimes if you're not careful, then you'll miss it. Well, what corresponds in this? We only have one thing left, really, right? Okay. So 5x set corresponding parts equal. Okay. Then we just solve. So x is 9. And we're done. So being careful that you compare corresponding parts. Again, this is not a triangle. But just as a reminder, the name will tell you. Like B and F are both the second letter. So that tells you that they are corresponding parts. Similarly, if I say AB, that's the first two letters. That corresponds to EF. That's the first two letters of the other figure. So anytime that it gets kind of sticky and you're not sure, use the name. That will help. Okay? All right. Here's a word one. If cow is congruent to pig, and now you have to make sure to label correctly. Do you want to try this one? Do you feel comfortable with that? What should you do when it's just words? What should you do? Draw a picture. So just looking at faces, I want you to do this one. It's a little bit formatted weird, but can be tricky. It does not matter how you draw the first triangle. So I'm just going to label in order COW. From there, start labeling what's given. CO is 25, CW is 18, and then the other information goes in the other triangle. So again, the first triangle doesn't matter how you draw it. Just draw a triangle, label it, and then put the stuff you know on it. However, the second triangle has to match this. It's important that you make sure the parts correspond. So C has to be with P. And it helps if you draw it in the same orientation so you don't trick your eyes. Like, don't make this harder on yourself. So C, because it's the first letter, it has to go with P, the second letter. So this has to be a P. And then O, same thing, has to go with I. So that would be up here. And then G and W go together. So use the names to help you. And in the way I drew it, that's where G would go. You could draw this any number of other ways than that's different than mine, but you have to make sure the parts that go together are in the correct place. Any questions on that? Okay. Now we can label IG as 23. PG is 7x minus 7. So, with that setup, and we were told these are congruent, so we don't have to prove that part. Okay? Like, that's probably worth highlighting this right here, that it's true. So we know these are congruent, so now what parts correspond? Okay, 25 goes with something we don't know, IP, right? But we do know that IP is now 25. OW is 23 because it corresponds to 23. To solve for x, we need to know that these two bottom, the way I've drawn it, the two bottom pieces are corresponding. Okay? So 18 and 7x minus 17. So x is 35, is 5. And then it says find PG as well. So 35 minus 17 is 18, which we already know, right? Because it was corresponding to the 18. How'd that go for you? Okay? Definitely draw a picture. It's always helpful in geometry to have a visual reference for your work. Okay. Here's some different versions of these. You can take a look at the top one. You see how it's kind of busy? Because these problems have overlapping triangles, is what we call them. And that makes these a little bit harder to see stuff. So we'll tackle that tomorrow. I'm not saying they're necessarily hard, it's just a little bit more involved than what we've done so far. Okay? So don't pack up, we still have 5 minutes. Just so you know. So actually it's a little more than 5 minutes. If you look at the back, it's proofs. We're not there yet, but so we're just doing the front. So you can go ahead and work till the bell, and then we'll pick up with checking and more solving tomorrow. Yeah, maybe get into some proving. That'd be good, wouldn't it? You guys have missed proofs, I think. Yeah, they're alright. Better than what? Better than Algebra 2. Didn't we establish nobody in here's taking Algebra 2 next year? Well, just Bailey. You might? Yes. Sophia, how about you? You're going to take Algebra 2 next year. Huh? Yeah, well, I mean, you need to get your math credit. What did you ask? Yeah, pretty much. Yes. Well, for sure then, but yeah, algebra, geometry, algebra 2. If you absolutely know you're never going to college, I suppose you can take something else for that third credit.
Some people
You what? You redid it?
I redid it.
Oh, you already? You think?
No, I think.
So you obviously learned a lot. If you can't even remember it.
No. I passed both of them.
Okay. Both of what?
Both of them.
Algebra 2 is a good class, but harder than geometry. This class. It's definitely easier than algebra 2.
Oh, yeah.
Yeah, for sure.
Some people don't really like taking algebra 2 because they have topics. So they do topics. Algebra.
That's interesting. Topics isn't even a high school math class. It's pre-algebra.
I think, yeah, my friend had topics. I never did.
Yeah. Yeah, you hated algebra 2? With a passion. You're more of a visual geometry guy? That's good. I wonder how you guys will feel about our probability unit, which is neither algebra nor geometry.
Is that for part B?
We might squeeze it in before Christmas. We'll see.
I'm not going to be there after.
What?
I already have part B.
You can still come just because you like it. Well, are you graduating in December or just don't have to take math?
Don't have to take math, but there's a possibility of taking math.
So we can just work and make money.
We'll go to either join a labor union or maybe CCC. Oh,
No, those parallel lines tell you a bunch.
Right.
What do they tell you? Oh yeah, you mark that line in the middle as reflexive, so you have the side. But parallel lines tell us all about angles.
So like,
So which angles do we notice within the bathroom? No.
All in the back.
Well, okay. Technically, yes, you do know that those are congruous, but we haven't learned that yet, so you're gonna have to do this. Because what you marked was true for a parallelogram, but it's not super helpful because we're trying to prove these two triangles are congruent, not the whole thing. So what other angles can you mark?
Friday and Saturday.
What?
There's a big time wrestler coming. And doing the wrestling thing here. So that's gonna be fun.
Yeah, that'll be cool.
He's only allowed to do four of them each year.
And you got to go.
Well, no, it's gonna be here at school for Friday and Saturday.
That's cool. So what other angles are doing something about? No? Have a good day, buddy. See you. Maybe tonight go home and review your parallel line stuff. 'Cause that's this, but also that was an issue on this test. Do you still have those papers?
Have a good day.
Thanks, Kyron, you too. Do you still have the parallel line paper? So go study that tonight. So yeah.
well, so